So this is question 2 in the probability random variable question set. We have been given information on a random variable that was labeled x and should be the number of incoming planes every k minutes at a large international airport. So we are also given a probability mass function. Why is it called mass function? Because this is a discrete random variable which can take these values. Okay, smallest value is 0, no plane, but then we have natural numbers 1, 2, 3, 4. So we have a discrete random variable, and therefore it's not a probability density but a probability mass function. That means whatever we calculate here, we can actually interpret as a probability which is different to a density. So it turns out this is a Poisson random variable, and you can look up on the Poisson section to see the similarity. The value k is in a way a parameter here. Okay, so that is a parameter for the distribution, and depending on different values of k's, this formula will change. Let's address the first question. What's the probability that exactly 9 planes arrive during a 5-minute period? So basically we're saying here that k is equal to 5, and we want to calculate the probability that the random variable x takes the value 9. And from here onwards we just need to plug in values into our mass function. So that's 0.9 times 5 to the power of 9 divided by 9 faculty times the exponential of negative 0.9 times 5. So it turns out, just simplifying slightly, 0.9 times 5 is 4.5, so we're having 4.5 to the power of 9 divided by 9 faculty times the exponential of negative 4.5. So this is all just calculations. Of course you need to know how to calculate this guy. This guy is of course just 9 times 8 times 7 and so forth, all the way down to times 1. That's a pretty big number. You check out yourself what it is. Turns out that altogether, once you do that, what we get is approximately 0.0232. So approximately 2.5% is the probability that we get exactly 9 planes in 5 minutes. Part 2. Fewer than 5 incoming planes. So what's the probability of having fewer than 5 incoming planes during 4 minutes? So firstly, k here is 4. Okay, these values here, and that is going to be k. So k is equal to 4. Fewer than 5 incoming planes. That means what we want is the probability of x smaller than 5 is the same as the probability of x being 0 plus the probability of x being 1 plus, and so forth, all the way to plus the probability that x is equal to 4. So these basically 5 terms which we have here, there are 2 hidden in here, we need to calculate. Each of them is calculated like in part 1, calculation like this. Now this will become a bit tedious. That means that from here onwards we will use Excel to calculate these terms. Before we do that, let's look at what in principle we will need for part 3. So here we have at least 4 incoming planes during a 2-minute period. So here k is equal to 2. Here we want the probability of x being larger or equal to 4. So there's going to be the probability of being x equal to 4 plus probability of x equal to 5 plus, wow, and now we can go a long way. In fact, you can go an awful long way. Now there could of course well be a maximum limit for planes coming in. We aren't given any here, and the Poisson distributed random variable assumes, as you can see from here, that this number can basically go to infinity, even though probabilities for large values of x may very well be very small, as we will soon see. But you can see calculating this term by just adding up all possible individual values is infeasible here, because we will have an infinite number of these terms. So we need to find a slightly cleverer solution. We know that if we add up for a discrete random variable the probability of all possible outcomes, we get 1. Therefore we use that information to recognize that this probability is the same as 1 minus the probability that x is smaller than 4. And that is the same as 1 minus the probability that x is equal to 0 plus the probability that x is equal to 1 plus the probability that x is equal to 2, and lastly the probability that x is equal to 3. And then we close this square bracket. Okay, and now we've transformed this probability in a probability where we only need a finite number of terms, which we can calculate as in part 8. All these calculations we'll now do in Excel, so we'll switch to Excel. In Excel we should now recognize that we have values of x that can take we should now recognize that we have values of x that can take, or the random variable x can take values 1, 2, 0, 1, 2, 3 and so forth. So we'll allow for a few values here, calculate all this. Now we want to calculate the probabilities that big X is equal to little x, and perhaps I should use a little x here. And now we need parameters. What we need in particular is the k. And just to confirm that this works, what we're gonna do is we're gonna repeat the first calculation where k was equal to 5 and x is equal to 9. So k, we'll just use a 5 here. Let's go to x equals 9. So what we wanted to calculate, or what we needed now to implement, is our probability mass function. And that worked as follows. We have 0.9 times k, so I refer to this. I'll fix it because we'll copy that cell later, and that was taken to the power of 9. Then this was divided by the factorial, and in Excel you use the command fact, and that of 9 again. So that completes that first term, and now we need to multiply with the exponential of negative, and what we had here was negative 0.9 times that parameter k again. So that was our formula. Now that k should be fixed again. We'll put dollar signs in front, and we enter, and we get of course approximately the same results. In the previous calculation there were slight rounding errors, but we are still at 2.3%. Now we only calculate that for one possible outcome, x equals 9, if we just copy that cell up and down, we can easily calculate the appropriate probabilities for any number of planes. So if you just look at this formula here, we see it still refers to the k because we fixed that, but now to outcome 5. And that will now make it very easy for us to calculate the solutions to the remaining problems. Let's look at the second problem. Here we had k is equal to 4 and we wanted outcomes of x smaller than 5. That means we needed to add up all the probabilities from 0 to 4. So the important thing is we need to change our parameter to 4. Change that here and automatically all the values will change. It may be quite instructive. We can just briefly do that to give ourselves a probability distribution. Here is our probability distribution. So let's just see how that changes between 4 and 5. Okay, so you can see it moves a little bit to the left. Mass moves to the left. Now to answer our question, what we needed was we merely needed to sum up the probabilities from 0 to 4. And the result is 0.7064. So here the result is 0.7064. And what about the last question? K changed to 2 and we wanted to calculate 1 minus the sum of the probabilities for outcome 0 to 3. So important, K needs to change to 2, and then we don't need that anymore. Instead we wanted 1 minus the sum of outcomes 0 to 3, and we get 0.1087. So here the outcome is 0.1087. That is it.